The second project is about regression analysis. It is a statistical process for estimating the relationship between independent variables and dependent variables. It is a way to find trends in data. Its result is a representation for the data set. There are variations, linear, multiple linear, and nonlinear. The most common models are simple linear and multiple linear. Choosing an appropriate regression model is often a difficult task. In this project, you will try to find best regression models for given data sets. Here is a common strategy for the determination of the best model. We assume we are given a data set as in this figure. First, we may plot the data set for a visual inspection. Then we can select one or more good models. Then finally, the best model is determined through analysis. Let's do a visual inspection. For this model, it looks like the best model is a quadratic polynomial. This side is a bit increasing so that it is not exponential tendency, so that quadratic polynomial seems the best choice. Okay. Now for this data set, here we try to find a polynomial model in this form. It's a quadratic polynomial. For the data set, we consider this model, and for each point, there are n points. For each point, we try to get predicted value that is from the model, and this is from the data. And yi is not the same mostly, but anyway, we write in this way, and we try to use the method of normal equations. From second point, we have this equation and go down, and from the last point, we have this equation. Then we can write these equations into this system. xp equals y. X is the quotient metric or the information metric. 1. There's coefficients over there all way down is 1. And quotients of A1 is now x1 to xm. Now quotients for A2 is the x value squared. So we collect the coefficients, and P is the parameter vector, unknowns, and Y is the right side. Now we apply X transpose both sides of this equation. Then we reach at the normal equations. So here, this metric times P called right side. And you can see a pattern, this summation of 1, and along this horizontal direction, xi power is increased, xi summation, xi squared summation. Also, in down direction, you can see that is now xi multiplied and xi squared multiplied. And for each row, again, along horizontal direction, xi power, it is increased by 1. You can see the pattern. And also right hand side, first one is y summation. now x is multiplied and x squared is multiplied. So you can see pattern. The polynomial fitting is well implemented in most programming languages. In MathLab, you can find the polyfit. These are x values, y values, and degree, the polynomial degree you can choose. In Python, in the package NumPy, you can find the polyfit. You can use it the same way. And in this project, we'll use it. Sorry about it. Okay, here we have a program in MathLab. We read the data set that is saved in this data, and we are considering right now this data set 100 points, and x and y, and separate the first column, second column from the data set, and we are using polyfit. And also now here, and we can, that is now the y value can be predicted. Okay, also we can measure y values for the same x point. Now, along with this polynomial coefficient, we can evaluate along the model y hat is made, and then here least square error is measured. Okay, and that is output. You can see that, and the value is 0.13, which is minimum possible the squared error. Now also P, the model, that is now the coefficients of the quadratic polynomial. Okay, and here try to get regression curve. We chose 100 points, and between now minimum x value to a maximum x value, and 100 points. For the points, the polynomial is values are evaluated, and then we try to make the plot. Okay, so that this red curve is quadratic polynomial, and this is original data set. You can see really quite good representation. Okay. Okay. Now, when you you consider nonlinear regression, then in some cases you can make linearize the model. For example, for this data set, here looks like exponential model. So we consider y equals c times e to the dx. Now in this case, c and d are unknowns. So you have to minimize this one, so that once you consider nonlinear least squares model, then now this is a predicted value, this is observed value, the error square must be minimized. In this way, you have to find C and D. And you can solve the problem by using some Newton method or some gradient descent method. Either way, you can solve. However, it is not easy. You have to give really good initial value for C and D. Without that, it is not well working. And also, the convergence may have some issue, so that we may try to get the solution through linearization. For example, here for this model, we use change of variables, and we apply first and logarithm both sides. Then logarithm y is logarithm c times e to the dx. Then using the property of logarithm, we reach out this one. After this transformation, we introduce now new variables. So it is a kind of a change of variables. Define capital X is X, and Y as logarithm Y, and A is logarithm C. Then this equation becomes now linear model Y equal dx plus A. And by using polyfit, we can get dA, these unknowns. And then now for C, here, using this equation, we can recover the C value. C is exponential of A, right? Okay, in this way, we can get the best exponential model through linearization. Okay. Let's see here for the data set. Okay, assume we saved it and read the data set, and now get X component, Y component, and here for Y, we introduced change of variable that is a logarithm Y, and capital Y is a logarithm Y. So we name here logarithm Y, and using X and logarithm Y and linear model, we got it. And then here C is recovered from this A value. So we can measure now least squares error and print out to see what the result is. Now C and D are this one, and least square error is a little bit larger than 4. And the model is fitting the data set quite nicely. Okay, for the above the data set and program you can download. Okay. Now let's go to our main subject, finding the best regression model. So we begin with an example. Consider a simple data set which is made from a sine function. I chose 10 points on the sine curve, and then perturb by using a random value, so that we collect this 10 value, and from this data set, let's try to find the best regression polynomial. And that's what we want to do right now. And here, I implemented this program in MathTalent, and beginning point is 0, end point is 1, and there are m point for this one, for this sine curve, and there is a function, and then theta file name is this one, and okay, and this the parameter is used here once we want to renew data set. Then you change this one to be 1, non-zero, then this will be executed. However, if we choose this one, and also the data file exists in the directory, then the program will read the data set. Otherwise, now here x and y value is made from the function, and then by using random noise, it'll be perturbed so that these data points are made through one execution of that one, and then after making it, and it is saved. So along with this 0, and it'll be used again, if you call this portion. If there's no data set, then it'll be executed this portion, okay? In Python, you can use this command, read metric and write metric in MathTalent are respectively here load text and save text in Python, okay? Okay, this is about data creation and data reading, and then this portion is now from the data set, and x component, y component are separated, and for degree is moving from 0 to m-1, m is 10, and so that degrees from 0 to 9, we try to make polynomial fitting. And then we measure the error, and also we try to make the figure. But here now, I have a function save figure, and along with certain name, it is automatically saved. But in this execution, I committed out anyway. Okay, here, once we try to see the figure for polynomial fitting, once n is 0, then this fitting, n is 1, linear, we have this one, quadratic, cubic, and fourth order, and fifth order is almost the same. So I jumped, and then sixth order, polynomial fitting, and seventh, eighth, ninth. For ninth order polynomial, there are 10 points, so that, in fact, it passes through all points. So error will be 0. But from here, it starts oscillations. So it looks like the best model is around there. And we'll try to choose the best model through analysis. Okay. The question is, which model is the best? Okay, I forgot H here. Okay. Now, for an analysis, let's try to measure the least square error. So once we have nth order polynomial, then for each point, we have a polynomial prediction, and given observed data y value, and error square sum is the error for nth order polynomial. Okay, so for this data set, I measured the error, and it's going down, and then when n becomes 3, rapidly going down, and from 4 is slightly go down. It should be, once you choose n, the degree of polynomial larger, then the error becomes smaller. However, up to this point is rapidly going down and slow down, and then at the last moment, the error must be 0. Okay, this is the profile of the mean square error. Now, strategy in choosing the best model is given here. given several models with a similar explanatory ability, so it's around there, it's similar. However, for that one, you have oscillation. So that you may try to choose from 3 to 7. The simplest is most likely to be the best choice. So that start from a very simple model and only make the model more complex as needed. So if you reach at 3 and 4, it's not significantly improving. So in this case, now best choice must be third order polynomial. That is common strategy in the world. Okay. Now here we have project objective. We'll try to find best model for each of these two data sets. You can download clicking these two lines. Okay, here there's data 1, there's data 2. It looks like a quadratic. And this one looks like a quadratic, but not really, because the data set has a cursor. So you may consider this one as some locally linear. Okay, data 1, data 2. Okay, here we have what to do. First, download these two data sets and try to find best models for data 1, and you may check if one of them is better. So one is quadratic, the other one is exponential. And for second data, and you I'll ask you to here analyze like in this figure, and try to get linear and constant linear, quadratic, cubic, and so on. Try to check if polynomial fitting, and you will see also from certain moment some oscillation, and just try to get the best fitting model and degree of the polynomial. So you have to claim with your computational support. Now, for all models, measure the least square errors and show them in a tabular form. Now, in third one, and show figures, and particularly like in this one, okay, in this one, and for error like this one, okay. Okay, now this part is extra credit one. Find the piecewise regression model for the second data, and for this one, you may try to separate the data set into two portions by choosing a vertical line right left of this point, and you can separate this one or that one, or you may consider a line passing this one, so that this is the first part and second part. For each part, try to get a linear model. Then you can find the line and another line, and you can also find here the intersection, and up to this intersection you may draw this portion. From this intersection you may draw that portion, so that you can make really good piecewise linear representation. Okay, that's the extra credit problem. Is it better than polynomial models? So you can measure the error when you do this way. Then you can measure the error, and so that for this error, when you are using the polynomial fitting, then you already know the errors, and then the error from this fitting, multilinear fitting, you can compare so that you can claim which one is better. Okay? Here the final note. You may use parts of the code shown in this project section. Report your code, any implementation you made, and numerical outputs and figures with a summary. If you don't add the output results, then I'll not give you any credit. The summary will be worth 20 points, the full credit. So it is a 20-point worth. And include all into a single file in PDF or Microsoft document format. I hope you enjoy the project. Thank you.